Okay. There are two division methods for division of polynomial methods mentioned in the homework in this section, in this section. One is called long division, which is the process that you're used to doing with arithmetic. It's just that it will be with algebra now. And the other one is called synthetic division. I do not cover synthetic division. However, some of you might read that section and decide you like synthetic division better than long division. I do not care which one you use. They both will give you the same results. They're just a different approach. So if you prefer to use synthetic division, okay. But most of the homework I selected for you is going to involve long division. Again, you can substitute one for the other to get the right answer. However, I picked one or two homework problems that says use synthetic division because I liked the problem. However, since I'm not expecting you to know synthetic division, when you read those homework problems, just put a little strike through it in your mind and read it as use long division, okay? But if you like synthetic division, you can do synthetic division. It's just that I'm not requiring you to know both, okay? Is that clear? Might sound a little fuzzy, but basically where you see synthetic division, cross it out and do long division. Okay. So let's take a look at long division as we normally see it with this first problem. 637 divided by 21. Let's learn some language for a minute that may be a little fuzzy if you ever knew it. I don't know. Sometimes people know this language, sometimes they don't. The number that you are dividing by is called the divisor. That is probably one word that kind of makes the most sense. So 21 is the divisor here. The number that's actually being divided, and if you're lucky enough to have some kind of stock options or whatever, and you get dividends or you earn dividends on something, those are spread and split. Those are divided. The thing you're dividing by is called the dividend. Your answer, once you get it, is called the quotient. The quotient is the answer to a division problem. Okay, so that's always what we refer to as quotient. So I was trying to figure out why it was called quotient, and I figured it had QUO, had to have some kind of Latin root. And one of my students who's taken Latin in my first class looked it up, and it's a question that means or is in the place of, or something like that, in the place of. And given that our answers always has to be, all the place values need to be lined up, I guess that makes a little sense. So let's take a look at this first problem. We want to do 637, so you may want to change that on your lecture notes. I try to get all the sixes changed, all the sevens changed to sixes, but I forgot that one. Okay, so 637 divided by 21. We want to write the answer as a quotient with the remainder divided by the divisor as our fraction left over. Okay, so I want to mimic for you what most of us learned as an elementary school child. We learned an algorithm for this, for long division. And for many students, it made absolutely no sense. They just memorized divide, multiply, subtract, bring down. I mean, when my daughter came home and that's how she did division, I was like, okay, do you know what you're doing? Nope, but Mama, these are the rules. These are the procedure. And part of why a lot of students initially, sometimes when I used to teach one of our beginning math classes and I would ask students what the barrier was for them, some would say fractions, some would say division, and some would actually go as far back as subtraction. And one of the problems is that US students are really are not taught in a way that focuses on place value. And so what we usually say is incorrect, but tell me if this is usually what you would say when you approach a division problem like this. You say, oh, 21 goes into 63 3 times. 3 times 21 is 63, subtract 7. 21 goes into 7 0 times, remainder 7. Is that kind of the language you would use? Yeah, okay. So here's the issue. The issue is it's not a 63 here, it's really 637. And when you kind of ignore that 7, you're really saying 630. And really what you're doing is kind of 20 into 600. And notice where you write the 3. you write it above the tens place. So it's really not 3, it's 30. All right, and then when we do this subtraction, what we're really doing is 630, and then we're bringing the 7 down. So the place value is important. Where you put the 3 and where you put the 0 is really important. And young students who don't have a sense of place value, sometimes they might put the 3 over above the 6, and then they fill in with 0 zeros, and they don't have a sense that 300 times 20 is way too big. It couldn't possibly be 637 because their sense of place value is off. So what I wanted you to see is this is how you may write it. The other way you would write the answer here is like this. It's if you do 637 divided by 21, you get the following mixed number. 37 21s left over. Okay. Now, how would you check this particular problem? How would you check that 37 21s really is indeed 637? What would you do? What would your process be? If I asked you what that equaled. Yeah, what would you multiply? Yeah, 21 times 30. And then what would you do once you got that, Jane? You add the remainder, right? So that would give you 637. Okay, so to check, you take your divisor times your quotient and you add your remainder, and that gives you 637. All right. So what I want to do today is I sort of want to mimic what is really going on here with a problem where you've actually sort of spread out your place values or you've created terms, because this is going to look like an algebraic problem in a minute. And what I mean by that is just imagine that you let x equal 10. If x equaled 10, how could you write 20? What would 20 look like if x equaled 10? 2x. And then 1 would just be 10 to the 0 power 1. All right. What would 600 look like if x was the number 10? Just keeping the 6 with a place value. Yep, it would be 60x, but we can keep going to mimic the place value of 100 here. What square equals 100? What? Oh, I already gave the answer away. 10 squared is 100, right? So it'd be 6x squared. Then how would we write 30? 3x. And then we'd have our 7 ones. Right? So if you want to imagine this arithmetic problem looking like an algebra problem where you let x equal 10, for example, then 20 plus 1 would be 2x plus 1. 600 would be 6 100ths. 6 times 100, which is 6 times 10 square, or 6x squared. 30 is 3 times 10, which is 3x, and then you have your 7. So everything we're going to do now with the numbers, we can transfer and do it with the algebra, the same process. And how you begin is you start with your biggest place value, which in your dividend is the number 600. And you start with your biggest place value on your divisor, which is 20. And you say, how many times does 20 go into 600? And your answer is 30. And you have to line up your 30 above it, the like place value, which is right here. 30. Then what you do is you take your 30 and you multiply it by the 20, which is your 2, and your 1. Now when it's a number, we just do them both. But what a lot of students never learned is when you actually take 21 times 30, for example, another way to write that is 20 plus 1 times 30. And you just do 30 times 1 and 30 times 20 is 600. So that's 630. And what a lot of us learned in school is we did that, and then we were told to move in one place to the left. The reason? Because now you're doing 30s times 1s, which is going to give you 10s. So when you put the 3 there, that's really 30. See, here's with, if you put that 0 in there, and then 30 times 20 is 600. Notice you've lined up your like places. There's your 630. But most of us are not taught place value algorithms. We're just taught these quick, efficient algorithms that to many of us don't make any sense. There's lots of ways to divide. There's lots of ways to multiply depending on what country you went to school in. Okay, so we say 30, and then 30 has to multiply the 20, and we write underneath 600. And then 30 has to multiply the 1, and we write underneath 30. And then we're asked to subtract. Now, when it's just a number over here, we just do the subtraction in one fell swoop. Here we have to subtract both of the terms. We have to subtract the 600 and we have to subtract the 30. So both of those signs change. Look, this gives us a 0, that gives us a 0, and the only number left is our 7, which is remainder 7. Okay. Now, what I want to do for you is I want to do an algebraic problem similar to this. So let's go move on to our first algebraic problem. So here's our dividend, 6x squared plus 5x minus 6. The first thing you want to say is our polynomial here, is our trinomial in descending order? It goes squared term first, first power, a quadratic term, a linear term, a constant term. It's in descending order, no problem. Make sure your dividend is in descending order. You've got your linear term first, x to the first, and your constant second, no problem. So you're all set to go. You write 6x squared plus 5x minus 6, and you divide it by 2x plus 3. So where do I begin? Okay, where do you begin is you start with the highest place value in your dividend, which is your 6x squared. Your leading term, so to speak, is like your highest place value. And you start with your leading term in your divisor, and you say, how many times does 2x divide into 6x squared? So you do that division out off on the side, or some of you can do it in your head. 6x squared divided by 2x is 3x. And now the trick is that you have to move in and line up your like terms, which we called like place values. There's your 3x right above the 5x. Okay? Now you take 3x and you multiply it by both terms. You use your distributive property. You multiply it by both terms in your divisor. And when you do your first multiplication, 3x times 6x, you better get exactly the first term in your divisor or you've made a mistake. These two should always be identical. Then 3x times a positive 3 is a positive 9x. Okay, so you say, all right, now I have to subtract that. Remember, you've got two terms here, so you have to change the signs of both terms. The 6x squared now becomes negative. The 9x also becomes negative. And now you add them, right? And that becomes a 0. And this becomes negative 4x. And now you bring down your next term, which is negative 6. And so now you have a brand new dividend. Your new dividend now is negative 4x minus 6. So you look for your leading term, which is negative 4x, or your highest place value if you were thinking of numbers. And you start the process all over. You say 2x goes into negative 4x. So to do that, I say negative 4x divided by 2x. My x's cancel and I get negative 2. So that's a 1. Ones place, so I go up here and I put negative 2 in my ones place, right above my negative 6. And now I start my multiplication. I say negative 2 times 2x is negative 4x, and you have a little smile on your face because those two are exactly the same. And then negative 2 times 3 is a negative 6. And now you subtract both of them. And when you subtract a negative 4, it becomes a plus 4x. And when you subtract a negative 6, it becomes a plus 6. So that goes to 0, and that goes to 0. So your remainder is 0. When you have a remainder of 0, that tells you that 2x plus 3 divides into 6x squared plus 5x minus 6 evenly. There's no remainder, so it's a factor. So you can write 6x squared plus 5x minus 6. You can factor it to be 2x plus 3 times 3x minus 2. That's how you factor that second degree trinomial. Now, most of us, when we were asked to factor something like this way back in intermediate algebra, or even earlier this year when we were reviewing factoring, we didn't do long division. Some of us did trial and error, and we tried to figure out what factors of 6 we put in the first two terms and what factors of 6 we put here, so that it comes out to be 6x squared plus 5x minus 6 when we use FOIL. Okay, so one of my students in my first class said, Linda, couldn't I have just done it the old way? And I said, sure, but I wanted to start off with something that was a reasonable division problem. What you're going to be able to do today is you're going to be able to get division problems that you can't factor any other way except for through long division. The first thing I want to ask is, are there any questions out there about how I got 3x minus 2? Any questions? All right, so to check this, you would check it the way you check any division problem. Here's your division problem, and here's your answer, your quotient. To check this, you take your quotient and you multiply it by your divisor, and hopefully you come back to where you started. So if you use FOIL on this, 3x minus 2, there's your quotient times your divisor. And if you do FOIL, you get 6x squared plus 9x minus 4x minus 6. Get 6x squared plus 5x minus 6. So it checks. You feel good. Okay. Now what I want to do is show you something. Do you see that 6x squared plus 9x anywhere in your division problem? You see, yeah, it's right here, look. Do you see the negative 4x minus 6 anywhere else? It's right here. Because you're multiplying 3x times 2x plus 3, that's the first part of your FOIL. 3x times 2x plus 3, and then your negative 2 times 2x plus 3. So everything you do when you multiply should appear back here in your division problem. Okay, so let's take a look at another one. Sometimes you'll be given, in this case, we have a 4-term, we have a cubic, we have a quadratic, a linear, and a constant term, but they're not in descending order. So the first thing you want to do before you start your division is you want to line it up so that it's in descending order. You wouldn't write a number backwards. It's not going to have the same meaning, right? If you have the number 1,235, that's not the same as 5321. You have to put it in descending order, and the same is true here. Our divisor's all set. So before we start, here you have a cubic, right? 6x cubed, and you're dividing it by x to the first. What should be the degree of your answer? What should be the degree of your quotient? 1 less. It should be a square. It should be a quadratic. So where you start your answer is going to go right above here, right above your negative x squared term. Okay, because x to the first times x to the second is going to give you a cubic. Okay, so we start with our 6x cubed, and we divide it by our 3x, and what does that give me, Ricky? 2x, right. So where do I put the 2x, Ben? Can you tell me where I literally place it? Is it 2x? Should be 2x squared, right? Because above the negative x squared, right? So there we go. There's where we start our quotient. It's got to be a squared term. We figured that out before we started. Now we do our multiplication. So we do 2x squared times each one of the terms in the divisor. We have to use our distributive property. 2x squared times 3x is 6x squared, cubed, excuse me. You line that up and you say, oh, good, it matches. And then 2x squared times negative 2 is minus 4x squared, and you write that right beside it. Now you have to change the signs of both terms, negative, positive. When you're doing this long division, if you're using a pencil, it'd be nice to have a pen, or if you're using a pen, another colored pen, to just change the signs. So this goes to 0, and be careful here, you've got negative 1x squared here, plus 4x squared. So that gives you 3x squared. You bring down your next term, which is negative 5x. Now you say, how many times can 3x squared be divided by 3x? And what's my answer here, Adam? X, because 3 divided by 3 is 1. X squared divided by x is x. So I have 1x, and I put that right above its correct term, the like term in the dividend, which is negative 5x. And now I do my distributive property again, and I get x times 3x minus 2. X times 3x is 3x squared. And you say, that lines up good. And then x times negative 2 is negative 2x. Put your negative 2x. Now you subtract both terms. You change both signs. The first one will always go to 0 if you've done it correctly. When you add them, they're opposite. And then you have negative 5x and 2x gives you negative 3x. You bring down your next term, which is plus 4. And you've got one more division. You have negative 3x divided by 3x, which gives you negative 1. And that goes in your very last place. You line up your like terms, and there you go. And then negative 1 times 3x is negative 3x. And negative 1 times negative 2 is plus 2. And then you have to change both signs. That goes to 0, and we have a remainder of 2. Okay? So 3x minus 2 is not a factor of this cubic because we have a remainder of 2. It doesn't divide it evenly. Only when you have a 0 at the end is it a factor. Okay, so how would you write your division to this? How would you put your answer? You'd say my answer is 2x squared plus 1x minus 1, and the remainder is 2 over 3x minus 2. That's how you would write your answer. Just like we did before, 30 with 2 21s or 7 21s, whatever it was. Okay. So you have your quotient plus the remainder over the divisor. That's the form. When it's not a factor, that's a form they'll be asking you to write the answer in. Okay. Any questions on that? All right, so I want to let you have time to work on this. This division algorithm I took right out of your book. You can read it. It's just basically what we did. The divisor times the quotient plus the remainder brings you right back to where you started. And when you have a dividend that looks like this, notice you would say it's lined up in descending order, but there's places missing. When we don't have anything in our hundredths place, what do? How do we indicate that in arithmetic? We have a 0. 0 is a very powerful invention in mathematics. The same is true here. Anytime you have a dividend or a divisor where one of your powers of x is not there, you have to write it with a 0 in front of it as a coefficient. So before you do this division, you have to change your dividend to this. Just like you would do if that was the number 1001. You would have 1001. Same is true with algebraic long division. And then out front you have x plus 1. Okay? So I'm not going to do this division for you, but that's what you would do. And then you would say x cubed divided by x is x squared, and you'd write your x squared up here, and you'd go to town, and you'd start doing your multiplication, your subtraction, and you would have 3 pieces here on top. I don't know if they're pluses or not, okay? So that's how you would do a problem like this. So if you happen to get a homework problem where there's a term missing, you don't see it there, put it in and just put a 0 in front as the coefficient. Okay, so let's take a look at this graph. And this will be a little review of something you just did. If I asked you to write out this particular polynomial as a product of factors, which was the last problem on the first page of your quiz, should I be seeing pluses and minuses? Should it be in polynomial form? If it's a product of factors. No, it should be what kind of problem? All multiplication. Okay? So I am telling you here that this particular polynomial function has zeros at -2, which means -2, 0 appears as the x-intercept. 1 means that 1, 0 is your x-intercept, and 3, 0 is your third x-intercept. If you were going to guess the smallest degree for this polynomial, what would be the smallest possible degree for this polynomial, and how did you figure that out? 3. Why 3, Cameron? 2 turning points, right? 2 turning points, so n minus 1 is 2. The smallest degree would be 3. Okay? So when we look at a graph like this, we can immediately go up here and fill in at least most of what the polynomial equation would look like as factors. We don't know what A is. Till you tell me some other point on here I can't solve to find the value for A. But I can at least know something about A. What can you tell me about A based on this graph? What can you tell me about the value of A? It's positive, absolutely, because your right arm is up. Whenever your right arm is up, you're always positive. All right? So the first thing you do is you say, okay, I know all my factors have the form x take away whatever my intercept is, or whatever my 0 is. So if I take away a -2, this becomes x plus 2. That one's done. When I take away my next 0, it looks like that, x minus 1. And when I take away 3, it looks like that. They all have multiplicity of 1 because they go directly through the x-axis. They don't flatten out like the cubic does, okay? They go straight through. So they all have a power of 1. Each factor has a power of 1. And again, all we know about A is it's positive. Could be a half, it could be 10, it could be 0.9. I have no idea what its value is. All I know is that it's positive. So this is where we get 2 for 1. Okay? If you know that x plus 2 is a factor of this polynomial, then you know -2 is a 0. When you plug -2 into whatever the equation would be, out would pop a 0. You get 2 bits of information for the price of 1. If you know a factor, you know a 0. Can someone fill the next one in for me? If x minus 1 is a factor of this polynomial, then f of what equals 0? 1. Whatever makes this factor 0 becomes a 0 for the whole polynomial function. And finally, the last one, if x minus 3 is a factor, then f of 3 is a 0. Or vice versa. We can turn this around. We can say, I know that -2 is a 0 of the function. If you know it's a 0 of the function, you know that it appears as the x-intercept, and therefore x plus 2. If you replace that x with a -2, you would get a 0, and therefore your whole function would be 0 because you're multiplying by 0, and it's a factor of the polynomial. F of 1, F of 3, and vice versa. So this is just like Broadway. If you ever go to Broadway, you go to Times Square and you're trying to, get some tickets for a Broadway play, you go to what they call twofers. And twofers is my Boston accent, 2 for 1, right? So you go to twofers and last minute you can often get 2 Broadway tickets for the price of 1. Okay, so this is whole idea of the relationship between the zeros of a function and their factors is important enough that they call it a theorem, and that's why I have it in the box here. It basically says if c is a 0, if c is some number that makes your function 0, then you know you can automatically write down x take away c as one of the factors of your polynomial, and then vice versa. If you know x take away c is a factor, then you pluck off c, and when you plug it into your function, 0 comes out. Okay, so this is what the book refers to as the factor theorem, and this is how we use it. Solve this equation. If I asked you to solve this equation, right now you can't solve this because you can't use your quadratic formula because it's a cubic. You can't factor that right now. Right now you can't factor that. But if I said -2 is one of your zeros, then what does that mean? It means that f of -2 equals 0. So if you plugged f of -2 into this function and you did all of this arithmetic out, you would get 0. Okay? And if -2 is a 0, then what's one of the factors of this? What's one of the factors? X plus 2, because it's x take away a -2, which becomes x plus 2. So once you know one of the factors, you can do long division. You can take this polynomial and divide it by x plus 2 to get your answer. Can anybody tell me something about the answer? Anything about the quotient if I take this polynomial and divide it by x plus 2? Mary? It's going to be quadratic, right? It's got to be quadratic. Okay. So let's do long division to find the other factors. So here's my goal. I want to take 2x cubed minus 3x squared minus 11x plus 6, and I want to factor it. What's the value of a here? What's the value of a, the leading coefficient? 2. Whatever it is here, it's going to be part of your answer. How many factors am I going to have? How many possible factors could I have? How many possible zeros? 3. So maybe I can factor this, and this will be what it looks like. 2 will be on the outside because a is the same in both. Maybe I already know one of my factors. It's x plus 2. So I'm almost done, but I've got to do long division. So let's do it. 2x cubed minus 3x squared, oops, this should be 11x, minus 11x plus 6, the whole shebang divided by x plus 2. Okay, so I say 2x cubed divided by x, I get 2x squared. So I've got to move in one spot, 2x squared. I do my multiplication, I get 2x cubed plus 4x squared. I do my subtraction, and I get negative 7x squared. Now I bring down my next term. I have a new dividend. Here's my new dividend, negative 7x squared minus 11x. How many times does x go into negative 7x squared? Negative 7x. Now I do my distributive property. I do negative 7x times x plus 2, and I get negative 7x squared minus 14x. Change both the signs because I subtract is adding the opposite. That goes to 0, that goes to 0, and I get 3x here. And I bring down my next term. X goes into 3x 3 times. So I get 3x plus 6. Whew, this is going to be a nice one because my remainder is 0. So right now I can write this cubic as x plus 2 times 2x squared minus 7x plus 3. I'm almost there. So 2x cubed minus 3x squared minus 11x plus 6 equals, my 2 comes out front. I have an x plus 2 as one of my factors, and my other factor is this quadratic. So now the question is this completely factored? Can I factor this any further? Using any method, using your old method, a new method, and can we factor that? You could use the quadratic formula, which gives you the what? What's the solutions to the quadratics give you? The zeros. And if you know the zeros, you know the factors. Yes, you could use the quadratic. Or, and sometimes you're going to have to, I'll show you both ways, but we can factor this. You're looking for factors of 2 and your 3 that add up to what? 7. 2 and 3 that add up to 7. 2 times 3 is 6. 1 times 1 is 1. So you could factor this. You know both signs have to be negative. Okay, both signs have to be negative. You put your 3 here and your 1 there. You're done. Now, if these are the factors, x minus 1 is a factor and 2x minus 3, oops, yep, there we go, right here. I'm trying to hurry. If x minus 3 is a factor and 2x minus 1 is a factor, what are the zeros going to be? 3 and 1/2 if you solve these for x. So when you do the quadratic equation, what should you expect for your solutions to the quadratic equation? 3.5. So let's do it. 2x squared minus 7x plus 3, you set it equal to 0. A is 2, B is negative 7, and C is 3. X equals 7, the opposite of B, plus or minus the square root. B squared, 49, minus 4 times 2 times 3, all over 2 times 2, which is 4. Extend the page. X equals 7 plus or minus 49 minus 24, all over 4. X equals 7 plus or minus a beautiful square root, 25 over 4. 7 plus or minus 5 over 4. 7 plus 5 is 12 over 4. One of my answers is 3. 7 minus 5 is 2. 2 divided by 4 is 1/2. Okay. So x equals 3 is one of my zeros of the function solutions to the equation, also known as root. And to go back to your factor, you have to set this equal to 0. So you would subtract 3 from both sides. Voila, there's one of your factors. Your other solution is 1/2. Okay, you multiply both sides by 2. You make your right side equal to 0. Voila, your second factor. Okay, so that's how you could have done this with the quadratic. Yep, Mary? Here? Here? Because it's whatever a is on your polynomial, this is your leading coefficient. Whatever your leading coefficient is in polynomial form becomes your leading coefficient in factor form. That a is always the same, regardless of whether it's in polynomial form or factored form. It will always appear to be in both. Okay, it's always the same. Because if you multiplied this all out, Mary, x times 2x times x, right? Well, let's see. Did I do that right? 2x. That would give you a 4x cubed. All right, let me take a peek at that, because I do want to get you started on your group and activity, and I'll take a peek at that. Okay, so let's move on here. Could you write a possible equation for this? This is a little review of what you did on your test. We start off equation. We better have an equal sign, folks. Minus a 1/2 point, okay? F of x equals, we don't know the leading coefficient. Do we know anything about it? It's positive, so we can write up here a is positive. How many zeros do I have here? Well, we see 3 distinct numbers, but we're actually going to have more than 3 zeros because you're going to count them by their multiplicity. But what are they? Our zeros here are -2, help me, 0, and 1. Okay, so I get x plus 2, x take away 0, and x take away 1. And now I deal with my multiplicities. I go straight through, just like a straight line, at 0. So that has multiplicity 1. What happens at 1? What kind of function do I look like if I blow that up? I look like a parabola, don't I? That's multiplicity 2. And what about at negative 2 if I blow that up? It doesn't go, it goes through. It's got to be an odd number, but it flattens out. So what would be the smallest possible degree that could have, or multiplicity? 3. Right. So if we wrote this out the long way, we would write this: x plus 2, x plus 2, x plus 2, x minus 0 is an x, then x minus 1, x minus 1. So when we're counting the number of zeros, we count them based on their multiplicity. We say x equals negative 2 has a multiplicity of 3. X equals 0 has a multiplicity of 1. And x equals 1 has a multiplicity of 2. So we have 6 zeros. 3 of them are distinct. We have 3 distinct zeros, but we have 6 zeros for the polynomial because this is x times x times x times x times x. This would be a 6th-degree polynomial. We have 6 zeros, 3 are distinct. 3 zeros are distinct. They're different. But if you always count the number of zeros based on the multiplicities. Okay, we have about 5 minutes for you to start. Maybe you can get through this first one. I wrote in what the actual polynomial is here. If you can get through this first one, great. Let me check it. I will start here on Friday with you because I want you to have some time to work through this. And because of the quiz, we didn't get that time. So see how far you can get on this. Start. Okay. All right. So coming back to this, I would have put an A here and an A here. And when I found my zeros, I got 3 1/2. So I would have written this: x minus 1/2 and x minus 3. Okay. And if you take x minus 1/2, if you now multiply this through, you would get x times x times x, which is your x cubed, right? And you can multiply these in any order you want, like this. You could do the FOIL on this first and then take this. The 2 would be out here, and that's how you'd get your x cubed. So that would probably be, we would factor this as 2x minus 1 and x minus 3. And the 2, the A is already in there. But when you use your long division or your quadratic, you have to use the results, which is 1/2 and 3. And you go back and you put it in this form. So that's where your 2, that's why you could still write your 2 without, so you could write it this way. Okay. And I'll multiply that out for you down below so you can see how it all works out. So if we now multiply 2 times x plus 2 times x minus 1/2 times x minus 3, we come back to our original polynomial. So we go and we find the solutions or the zeros. The original coefficient is still the same.